Hello students, welcome to Basic Education. So we have a mathematics P2 November 2024. Okay, so the total marks for this paper is 150 and the time is allowed 3 hours. So the first question is question number 1. At the beginning of a season, the coach of a junior boys work by team recorded the weight in kg of the 15 players in his team and the number of push-ups that each player was able to do in 1 minute. The data is represented in the table and scatter plot below. The least square regression line for the data is drawn. So weight in kgx, these are this one, and the number of push-ups per minute, y is over here. So this is a scattered plot we have in this. So we have a total question is 6 and the question number 1.1 is determine the equation of the last square regression line for the data. So the first question is about round efficiency. So round, I'm solving the 1.1. So round coefficients we have rounding A and B to 2 decimal places. Rounding A and B to 2 decimal places. Okay? So A is approximately equals to 39 and 46 and B is equals to minus 0, 59. All right. So the equation we got from this is y equals to 39, 46 minus 0 and 59x. This is the required equation, okay? So what is the 1.2? Write down the correlation coefficient. No, in 1.2, we have to write the correlation coefficient, okay? So read the directly value from the calculator output you can take out. So the R is, we have minus 0 and 8, okay? And the question number 1.3 is predict the number of the push-ups that a member of a team who weighs 29 kg should do to meet the target, okay? So first of thing is substitute x equals to 29 kg into the regression equation that we do in 1.1 into the regression equation, which is we have y equals to 39.46 minus 0 and 59x. So what do we get? And from this equation, we get y equals to 39.46 minus 17. Sorry. We have a 46 minus 0 and we have 59 into 20 9 because we put the value of x. Now we got 3946 minus 17 and 11, and we got 22 and 35, the value of y. So the prediction is that the player should aim for approximately 22 push-ups per minute. So the decimal answer is mathematically correct for prediction. Okay. So the next question is 1.4. 1.4. In 1.4, write down the mean number of push-ups for the given data. So you have we have to calculate the mean of data. Okay. So as you can see over here, we have a mean. So find out the mean. The formula of mean is summation y and by n. Now we just add up 26 plus 21 plus 6 plus 20 plus 16 plus 26 plus 23 plus a huge number, 23 plus 7 plus 18 plus 14 plus 17 plus 8 plus 28 plus 25 plus 20, and this whole divided by, we have total 15 terms. Okay. So the answer is y bar is 275 by 15, and we got 1833. Okay, this is the required answer for it. Now move on to the question number 1.5, that how does the increase in the number of push-ups influence the standard deviation of the data? All right, so the first thing we have the transformation is y prime, which is equals to y plus 5. This is a shift in location of the data. Or data. So the second thing is shifting a data by a constant amount does not change the spread of the data. So the third thing is that the increase in the number of push-ups, we say the increase of number of push-ups will have no influence, on the standard deviation. So the reason is that the standard deviation stays as same. So why the reason is that the standard deviation stays the same. Okay. Now move on to the question number 1.6. Determine the maximum possible increases in the number of push-ups that a team member must obtain to reach the minimum target. So we have to calculate the required increase, the difference between the target and the actual. Okay, the difference between the target and actual. Okay, so the increase that is equals to y, which is 1586 minus 6, and we got 986. This is, we have an increase. Okay, so the maximum possible increase running contact. Okay, so I'm telling you the summarization. The largest possible increase is approximately 10 push-ups per minute, and the required player who weighs 40 kg. And this is the required answer for this question. Now we have a question number 2. The, the cumulative frequency graph shows the time taken for 60 employees to travel to work each morning. Okay, this is, we have a cumulative frequency and times or give, and these are the graphs, like, okay, like if you see that if time is 20 minutes, the frequency is 5, and this is gradually increases, and the peak point is 120 minute and the 60 frequency. So we have a first question is 2.1. Estimate the median travel time. Okay, so we have to estimate the median time travel. So I'm writing over here question 2.1. So position of median which is, we say Q2, is n by 2, and we have a 60 by 2, which is equals to 30. That means that 30th employee. Okay, so estimate or give estimate from or give is find the time corresponding to the cumulative frequency of 30. All right, so we have to find the time corresponding to a cumulative frequency of 30. Okay, so estimate from or give, find the time corresponding to a cumulative frequency of 30. So reading from the graph, y equals to 30. This is the y we have, which is equals to, you can see over here, 30, and we have a 60 minute over there. All right, so we say that a y equals to 30, so median is 65 minutes. Okay, 65 minutes. All right, so what is the second question? Estimate the lower quartile. Okay, the question 2.2 is, so the position of the lower quartile is, I'm going to come over here. The position of lower quartile is position of lower quartile which is Q1, that is equals to n by 4, that is equals to 60 by 4, which is equals to 15. We say that this is 15th employee. All right. So estimate from or give, find the time corresponding to the cumulative frequency of 15. And from, as you can see from the reading from the graph, at y equals to 15, we got Q1, that is approximately 44 minutes. Okay, so this is the required for 2.2. And the last one is that 2.3. Estimate the in quartile range. Okay, first of all, we have to quartile range. Now we have to estimate the in quartile range. Now for 2.3, we have to estimate the in quartile range. Okay, so position for upper quartile, which is Q3 equals to 3n by 4 and equals to 3 multiplied 60 by 4, and we got 45 employee. Okay, so estimate Q3 for from or give, we get Q3 equals to 84 minutes. All right, so calculate IQR. We got Q3 minus Q1, and Q3 is 84 minus 44, and we got 40 minutes. That is IQR. Okay, this is the required thing for this. Now we have a question number 2.4. The minimum and maximum times taken for an employee to travel to work are 5 and 120 minutes respectively. On the scale line, the answer book. Okay, draw a box and whisker a diagram to indicate the distribution of the data as represented in the algorithm above. Okay, so we have the minimum. We have minimum, which is 5 minutes. Okay, that is given. And we have Q1, which is 44 minutes. That is also we calculated from 2.2. And the median, which is Q2, which is 65 minutes. Okay, 65 minutes. So Q3 is equals to 84 minutes that we calculated from 2.3. So the maximum is 120 minutes, that is also given. Okay, so the required scale line, the graph is we have like that. Okay, as you can see over here, if I zoom out the graph, you can see over here, this is the time we have, and this is starting from this point, this point. Now we have this and this point, 30 and 60 minutes. So this is the cumulative frequency, and this is the times we have. Okay, and there we have a 45 and 80. All right, so the maximum, as you can see over here, is 120. All right, and the minimum is from 5. Okay, 20. So this is the answer, required answer for the 2.4. Okay, now we have the next question is 2.5. The company manager decided that all employees who travel for an hour or more will be allowed to work from home for part of the day. What percentage of the employee will be allowed to work from home for a part of the day? Okay. So criteria, first of all, we see the criteria is employee who travel for 1 hour or more. That's 60 minutes or more. And then second thing is that find the number of, first thing you have to see the criteria. Okay. So employees who travel for 1 hour or more. And the second thing you see, find the number of employees who travel less than 60 minutes. Okay. Read the cumulative frequency at t equals to 60. Read the cumulative frequency at t equals to 60 minutes. So we have a CF equals at 60 minute approximately equals to 26 employees. All right. So number of employees, the third thing is that number of employees who qualify for greater than 60 minutes. So number of who qualify, number who qualify equals to total minus CF at 60. So we say that number who qualify is 60 minus 26. That is, we got 34 employees. All right, number of who qualify. Okay, this is we have right over here. So now we have to calculate the percentage. The fourth point, we have to calculate the percentage. So percentage equals to number of who qualify divided by total employees multiply by 100. So what we got? The percentage equals to 34 by 60 multiply 100, and we got approximately 56.67%. Okay, approximately. So this is the required answer for the question number 2.5. Okay. Now the next question is about 2.6. Employees worked 8 hours in a normal working day. The manager decided on the following rule for time to work from home. An employee is allowed to work half an hour from home for each time interval of 20 minutes or a part thereof above an hour taken to travel to work. So on a certain day, an employee take 10 minutes to travel to work. Calculate the number of minutes that this employee will be allowed to work from home on this day. So we have total time travel is 110 minutes, okay? Total time travel equals to 110 minutes. All right? So calculate the excess travel time over 1 hour, which is like 110 minus 60, which is 50 minutes. Okay? This is the excess travel time. excess travel time. All right. So now determine the number of 20-minute intervals are passed thereof in the excess time. That we say that interval which is equals to 50 by 20-minute interval minute. Okay. Which is about, we have a 2.5 intervals. All right. So since the rule applies to each time interval of 20 minutes or past of thereof 2.5 intervals count as 3 full intervals. So we calculate the time allowed to work from home. Okay. The time allowed to work from home is 3 intervals multiplied by 30 minute by interval. Okay. So time allowed equals to 3 multiplied 30 minute. Okay. So we say that a time allowed is equals to 90 minute, or we can say that 1 hour 50 1.5 hour. Okay. So that is the required thing that we have to find out. Now we have a question number 3. In the diagram below, that triangle ACD has vertices A and C, where A is the point, the second coordinate, B lies on the side DC. Okay, this is, we have a triangle. A is the second in the second coordinate, and the B point is the in third coordinate. Okay, and the D point in the fourth coordinate. So we have to calculate. The first thing is calculate the gradient of DC. All right. So use the gradient formula. Use the gradient formula. M equals to y2 minus y1 and x2 minus x1 for D equals to 3.9 and C equals to minus 9 and 0. Okay, so MDC equals to minus 9 minus 0 by 3 minus into minus 9. Okay, so MDC equals to minus 9 by this minus multiply with this minus, it got plus, and we got 9, 10, 11, 12. Okay, now it becomes minus 3 by 4. So this is the required thing we have to calculate. Okay, we have to calculate the DC. So this is the gradient of DC. Okay. Now the next question is 3.2. Determine the equation of DC in the form of y equals to mx plus c. So 3.33. Okay. So use the point slope from y1, y minus y1 equals to m into x minus x1. with MDC, okay? So we are using the equation, like we have MDC that is equals to minus 3 by 4, and the point C we have is minus 9 and 0. And we have to show the equation in this, okay? So it's very easy. You know about the equation, which is we have y minus y1 equals to m into x minus x1, okay? So y minus 0 equals to minus 3 by 4, and we have x minus, and this minus we have a code plus 9, okay? So y equals to minus 3 by 4 into x plus 9, okay? Now I'm just going to multiply the values minus 3 by 4x minus 9 3 is 27 by 4. Okay, so this is the value we have. Okay, this is the required equation that we have to find out. And you can use the alternative using the t coordinate, which is 3 and minus sign. You can also get the point. Okay, now move to the next question, which is we have a 3.3, show that k equals to minus 6, okay? We have in the next question is 3.3, show that k equals to minus 6, okay? So point B minus 1k lies on the line DC. Lies on the line DC, okay? So substitute B into the equation of DC, okay? Substitute B into the equation of DC, all right? So we put K equals to minus 3 by 4 into minus 1 and minus 27 by 4, right? I just putting the value of B. So we have a K equals to 3 by 4 minus 27 by 4, and we have a 3 minus 27 by, sorry, we have a 4, and we get K equals to minus 24 by 4. And the required value of K is minus 6. So the coordinate, we have to show that K is equals to minus 6. Thus the coordinate of B are is we have a minus 1 and minus K, okay? And this is the required answer that we have to prove that K equals to minus 6. Now see the third question, which is, fourth question, 3.4, calculate the length of DC. Now, 3.4, okay? Calculate the length of DC. Length of DC, all right? So, using the distance formula, using the distance formula, which is we have a D equals to x minus x2 minus x1 whole square plus y2 minus y1 whole square, okay? So we have a point for D, which is 3 and minus 9, And we have a point C, which is -9 and 0. Okay, I'm just putting the values in the equation. We have -9 minus 3 square plus 0 minus 9 square. 0 minus 9 square. Okay? So what do we got? We have minus 12 square plus into minus 9 square. Okay? And we got 144 plus 81. And we got over here 225. Okay? So this is the value of DC, required value of DC. All right? Now, the next question is 3.5. Calculate the ratio of dB by DC. All right. So we have solved this question, okay, 3.5. So calculate the length of dB first. The length of dB, okay? So we have the D is coordinate is 3 and -9, and B having a coordinate -1 and -6, okay? So I'm just putting the values in the equation as you know about that. We have a dB. What we got? Plus 3 minus into -1 square. Sorry about that. Whole square. Plus into -9 minus into -6 whole square. Okay? So dB equals to a 4 square plus we got over here -3 square. I'm putting the square root over here. So we have a 16 plus 9, that becomes 25. And we say that dB equals to 5 units. All right? So now calculate the ratio. Now calculate the ratio, use dB by using dB equals to 5 and DC equals to 15, okay? So we got the ratio is dB and DC equals to 5 by 15. So we got dB by DC equals to 1 by 3. And that is the required ratio that we have to find out, okay? This is the required that we have to find out, okay? Now, the question 3.6 is that if M is a point on AD such that AC parallel to MB, okay, calculate the ratio of the area of triangle MBD and divided by area of triangle ACD. Okay, we have to calculate this. All right. So I'm writing over here the question number 3.6. So since AC is parallel to MB. So apply the proportionality theorem, okay? And by applying proportionality theorem, which is we also call it in triangle ACD, right? So what they says? This is that dm by MA equals to dB by BC. All right. So determine the ratio of dB by BC. We know about that a dB and by dc equals to 1 by 3. This means that dB equals to 1 part of dc and dc equals to 3 parts. Okay, so we say that a bc equals to dc minus dB, which is equals to 3 minus 1 equals to 2. Okay, so BC means that 2 parts. DC having a 1 part, DB having DC having a 3 part and DB having a 1 part, and we say that BC having a 2 parts. So the ratio of DB by BC equals to 1 by 2. All right. So determine the ratio of DM by DA from 1. So as you know that a DM by MA, which is equals to 1 by 2. So let DM equals to 1x. Let DM equals to 1x and MA equals to 2x. So DA equals to DM plus MA, that is 1x plus 2x equals to 3x. Okay? So we can say that dm by dA equals to 1 by 3. So now calculate the ratios of areas, ratio of the areas, use the ratio of areas of a triangle with common height or the area rule, area equals to 1 by 2 AB sine theta. Okay, so I'm just writing over here area triangle MBD, area triangle ACD, which is equals to 1 by 2 DM dot DB sine D divided by 1 by 2 dA dot dc dot sine d. All right, so the 1 by 2 and sine d cancel each other. Okay, so this is cancel out. So we got over here dm dot db divided by da dot dc, which is equals to 1 by 3. This is dm by dA and dB by dC equals to 1 by 3, 1 by 3. So we have over here triangle, area of triangle MBD by area triangle. This is not we have a writing over here. So ACD equals to 1 by none. Okay? So this is we have to calculate in this question. Now, move to the questions we have over here. So the question number 3.7 is that if it is a further given that the gradient of AD is minus 4 and the length of AD is 6 square root of 612 units. So calculate the coordinates of A. Okay? Now we have used the gradient 3.7. All right. Okay. By using the gradient of AD. Okay. So MAD equals to -4 as given, and we have the D points, which is 3 and 9, and let A point is X, A, and Y, A. All right. So just putting the values in the equation, we have a YA minus into -9 divided by XA minus 3 equals to -4. So YA plus 9 equals to -4 XA minus 3 minus 4 XA plus 12 YA plus 9. So YA equals to -4XA plus 12 minus 9. So YA equals to minus XA plus 3. So this is, we have an equation 1. Use the length of AD. So we have length of AD is length of AD, which is equals to 612 units. That is a given thing, okay? So AD square equals to XA minus 3 square plus YA minus into -9 square. And this thing is equals to 612 equals to, we have XA minus 3 whole square plus YA plus 9 whole square. Okay, so this becomes the equation number 2. All right, now substitute the equation 1 into equation 2, and how we get, okay, by substituting equation 1 into equation 2. So what we got? XA minus 3 whole square plus -4 into XA minus 3 whole square equals to 612. So XA minus 3 whole square plus 16 into XA minus 3 whole square equals to 612. All right, now do more simplification. We got 17 into XA minus 3 whole square equals to 612, and XA minus 3 whole square equals to 612. And we got XA minus 3 equals to 36, and for XA, we have XA equals to, we got over here, we'll take over here the square root. XA equals to, so XA minus 3 equals to plus minus 6, all right? Now we have an XA equals to, so XA minus 3 equals to plus minus 6, all right? Now we get the value of XA equals to 3 plus 6, and we have an XA equals to 3 minus 6, right? So just we have an xa equals to 9 and xa equals to minus 3. So solve for ya, substitute xa. So solve for ya. Okay. So substitute xa into equation 1. Substitute xa into equation 1. All right. What we got? If x a equals to 9, then y equals to minus 4 into 9 plus 3, which is equals to minus 36 plus 3, and that is equals to minus 33. And we got the points a is 9 and minus 33 in the fourth coordinate, okay? Now, if x equals to xa equals to minus 3, so ya equals to minus 4 into minus 3 plus 3. And this is equals to minus, positive, I take this. I think it equals to positive 12 and plus 3, this is equals to 15. So ya equals to 15. So the coordinates is a equals to a is minus 3 and 15, and it is in the second coordinate. So since a must be in the second coordinate, so x less than 0 and y greater than 0, so a is minus 3 and 15. Okay, this is the required answer that we have to find out in this question. Now we have a question number 4. In this question, in the diagram, this is the diagram, we have an endpoint with coordinates 1, 3 is the center of the circle. The circle cuts the x-axis at endpoint, okay? This is the endpoint. ST is the tangent to the circle at P. This is where the point P over here. This is the point P. And R, this is the point R. And with D greater than 0 and L lie on the circle, O and V are the x-intercept of PL and RL respectively. So this is the description of this diagram. So we have six questions of question number 4. So 4.1 is that write down the coordinate of L, okay? They give the coordinate of R, M, and P, and we need to find out the coordinate of L, okay? Let's do it. 4.1, okay? So L is the reflection of the center M across the origin O. If LM is a line passing through the origin, however, L and S appears to be in the y-intercept, okay? So, like if in the image, as you can see over here, which states that L is minus 1 and minus 3. So this is point dramatically opposite to the point P. P coordinates 3, 9. If M were the origin, so in the context of the diagram, in the context of diagram, okay, L and S are shown as the endpoints of the diameter. L and S shown as the endpoints of the diameter passing through M. The coordinates of M is 1 and 3, and O appears to be near the y-intercept. Okay, so assuming L is the endpoint, assuming L is the point such that LM is the radius, LM is the radius, and S is the other end of the diameter, and S is the other end of the diameter passing through L and M. Passing through L and M. Okay. So we say that XM equals to XM equals to XL plus XS by 2, and YM equals to YL plus YS by 2. So we can say that assuming the coordinates provided in the solution, like in the image, the coordinates of L is -1 and -3. Okay, because L is the reflection of the center M across the region. Okay, so the coordinates of L is -1 and -3, and this is the required thing which we want. Okay. Now, the question number 4.2 is that determine the equation of the tangent ST to the circle at P. Okay, so we have to find out the equation. Okay, so find the gradient of the radius MP. Firstly, find the gradient of the radius MP. Okay, so how you can find out the radius of MP? So we have the coordinates of M and P. So I'm just writing over here M P equals to YP minus ym by xp minus xm. We have a 9 minus 3 and 3 minus 1. We get 6 minus 2, which is equals to 3. Okay, now find the gradient of the tangent st. All right, the second point is you have to find out the gradient of tangent st. So the radius is perpendicular to the tangent at the point of contact. That means that MP is perpendicular to ST. All right. So we say that MST multiply MP equals to -1. And I'm just putting the values over here. m as t multiplied 3 equals to minus 1. So m as t equals to minus 1 by 3. All right, this is the gradient of the tangent. And now we find the equation of the tangent. Oh, sorry, equation of, now we find the equation of st. All right, so use the points or point slope from y minus y1. This equation y minus y1 equals to m into x minus x1. Okay, so with the points p, which is 3 and 9, and m as t is minus 1 by 3. So y minus 9 equals to minus 1 by 3 into x minus 3. All right, so I'm just writing over here and doing a little bit simplification. We got minus 1 by 3. This becomes positive 1. All right, and then this minus 1 plus 9. So we got over here y equals to minus 1 by 3. Sorry, we put the x over here, x plus 10. So this is the required equation that we have to find out for 4.2. Now, move on to the next question. And the next question, which is about 4.3, show that the equation of the circle with center M is x squared plus y squared minus 2x minus 6y minus 30 equals to 0. All right. So we have to show the equation of the circle with center of M. Okay, that's the given thing. All right. Now, move on to the solution. Now, the standard equation that we have, a standard equation, which is x minus a whole square plus y minus b whole square equals to r square. Okay, the center with m equals to a, b, that is equals to 1 and 3. Okay, so we can write this equation by putting the center. We have we put the values over here. We got x minus 3 whole square plus y minus 3 whole square equals to r square. All right, so calculate r square. Oh, sorry, we have put the wrong values over here. I'm just fix it out. Over there we have a 1. Sorry, over there we have a 1 because we have a 1 value over here. And over there we have a 3, okay? So now it's perfect. Now, calculate our square radius. Use the distance formula between M and P. So we have a distance formula by using M coordinate, which is 1 and 3, and P coordinate, which is 3 and 9, okay? So we have R square equals to M P square equals to 3 minus 1 square plus 9 minus 3 square, okay? So what we have to do, we am just doing the simplification. We got 2 square plus into 6 square, 4 plus 36, and we got 40 r square, and then taking square on when we taking square root on both sides like this. So we got square root of 40. All right, so now we have an r square value is 40 and r value is square root of 40. So substitute the r square and expand the equation. So I'm just writing x minus 1 squared plus into y minus 3 whole square equals to 40. All right. So this is the required equation that we have to find out. Okay. So let's move to the question number 4.4. Show that D equals to 7. All right, now. In 4.4, we have to show that D is equals to 7. The point R, which is D and 1, lies on the circle, lies on the circle. Okay, so substitute R coordinates into the circle equation. R coordinates into circle equation. Okay, so let's substitute the value of R. We have the equation x squared plus y squared minus 2x minus 6y minus 30 equals to 0. So the value of x is d squared plus 1 squared minus 2d minus 6 into 1 minus 30 equals to 0. So we have a d squared plus 1 minus 2d minus 6 minus 30 equals to 0, right? Now we have to make it d squared minus 2d and minus 36, it becomes minus 35. All right, now we need to, this is we have a quadratic equation. As you can see over there, we have a quadratic equation. Now what we have to do in this, I'm just doing the quadratic equation, and when solving this equation, we got d minus 7 into d plus 5. You can solve by factorization, and you can solve by the quadratic equation, okay? So we have a d equals to 7, and we have a d equals to minus 5. So since the question states that d is greater than 0, so we consider a positive solution of d. Hence the coordinate of r are 7 and 1. This is the required answer, okay? So move on to the next question, which is 4.5. Okay? So what the calculate the size of L. The size of L, okay? Now, how you calculate for it? This is like Miss Macy. Okay? Now, so we can say the first thing is that L is angle PLR or angle SLR. Based on the provided solutions, L refers to angle SLR, okay? So by using trigonometric rule, we have a method 1 by using the rule, by using the trigonometric with del PLR, right angle at R. The solution implies that P angle PRM is not 90 degree, but PRM is 90 because TR is the tangent at R. So the solution uses angle R equals to 90 for triangle PLR. So this is correct if PL is a diameter, which it is if L and P are endpoints of the diameter. So let's check MP and ML. So MP square equals to 40, and as you know that MP square equals to 40, as we saw in the previous question. So when you have an angle, triangle PLR with R is 7, 1, and L is, we have -1 and -3, and P is 3 and 9, okay? So this is the representation of the diagram, okay? So PR equals to, PR square equals to 3 minus 7 square plus 9 minus 1 square equals to -4 square plus 8 square, okay? So it becomes 16 plus 64, and which is becomes 80, okay? Now PR equals to square root of 80, that is equals to 4 square root of 5, okay? Now PL square equals to 3 minus into -1 square. Sorry, we did not put the square over here. We did not over here, we have a square over there, okay? Now we have a plus into 9 minus into -3 whole square, which is about equals to 4 square plus 12 square, that is equals to 16 plus 144, that is equals to 160. All right. So PL square equals to 160. When taking square root on both sides, we got PL equals to 4 square root of 10. All right. Now move to the RL, which is equals to 7 minus into -1 square plus 1 minus into -3 whole square. And we got 8 square plus 4 square, that is equals to 64 plus 16. And we got after RL square equals to 80. And after taking the square root on both sides, we got 4 square root of 5. So since PR square plus RL square is 80 plus 80 is 160, like since PR square plus RL square equals to 80 plus 80, that is equals to 160, or that is equals to PL square. PL square. So triangle PLR is a right triangle at R. Triangle at R, okay? Because we have an angle PRL equals to 90. So sine L equals to PR by PL, which is 4 square root of 5 by 4 square root of 10, that is equals to 1 by square root of 2. Okay? After doing the simplification. So we have an L equals to 45 degree. So this is the required answer that we have to find out in this question. Now, move toward the next question. So the next question is 4.6. PR is a tangent to the circle at R. Prove that. Okay, we have to prove that PT perpendicular to RT. All right. So that's very simple question. It's not taking too much time. So we have to find, first of all, we have to find out the gradient of M R of M. Okay. This is, we have to find out. So we have M coordinate, which is we have 1 and 3. And we have R coordinate, which is 7 and 1. Now we can easily find out the gradient. Now just put the values over here. We have M and R, 1 minus 3, 7 minus 1 equals to minus 2 by 6, that is equals to minus 1 by 3. So gradient of RT, tangent, okay? So we say that MR perpendicular to RT, so MRT multiplied by MR equals to minus 1. We can solve this in the previous question too. So in the next questions. So PRT multiply minus 1 by 3 equals to minus 1. So MRT equals to positive 3. Right? So gradient of PT from the question number 4.2, we can, previously in this question we find out ST that equals to minus 1 by 3 since T lies on ST and MPT equals to MPT equals to MST. This is we do in question number 4.2, okay? So we say that MPT equals to 1 by 3. Sorry, minus 1 by 3. So test of perpendicularity of PT and RT is MPT multiplied MRT is equals to minus 1 by 3 multiplied with 3, that is minus 1. So since the product of their gradient is minus 1, since the product of their gradient is minus 1, so PT is perpendicular to RT, okay? So this is the required answer that we have to find out in this question. Now we have in a question number 5.1. In the diagram line OP is given with P coordinate minus 3 and 4 and KOP is equals to A. So determine without using calculator the value of first 5.11 is cos A and 5.12 is cos 2A. So I'm solving the first 5.11, and before solving this question, we have to find out the radius, and just I'm writing over here the given things what we have in this, okay? Let us pull it out. Okay. So we have a given data. We have a P coordinates, and you can see over here we have a minus 3 and 4. And we say that on the terminal of arm of angle A, and A is the angle of KOP. So we say that X equals to minus 3 and Y equals to 4. Okay? Sorry, we have a minus 4 over here, right? Minus 4. So we have to calculate the radius, which is equals to R, and The formula is x squared plus y squared. And I'm just putting the values minus 3 squared plus minus 4 squared. And we got 9 plus 16, and which is equals to 25. And we got 5. So the radius is 5. Okay. Now we have to find out 5.11. Okay. So using the definition of cos A, by using the definition of cos A, which is we have x by r. Okay. So what the value we have in x? Cos A equals to, and we have the value of x is minus 3 and r is 5. So this is the required answer for 5.11. Now 5.21, 5.1.2 is we have to determine the value of cos 2a. Okay, so we're using the double angle identity. Okay, by using double angle identity, we have a cos 2a equals to 2 cos square a minus 1. And we already found out the value of cos a. So I'm just putting the value in this equation because we have to find out the value of cos 2a. So we have a 2 into cos a, what's the value of minus 3 by 5 square root minus 1. We got 2 multiply with 9 by 25 minus 1. We got 18 by 25 minus 1. We have a 25, 18 minus 25. Okay, and we got the value of cos 2a is minus 7 by 25. Okay. Now, this is the required answer for this question, and now we have a 5.1.3 is sine A minus B. If it is further given that sine B equals to 4 by 5 and 90 degree less than B less than 360. So we are given that B is sine B value and the range of B. And values from, we're taking the values of from the 5.1, we have a cos A. Okay, we just put the values in this formula. Firstly, if I'm writing the formula over here, the sine A minus sine B, like if I'm writing the formula of like sine A minus sine B, which is equals to sine A cos B minus cos A sine B. Okay, we say this is equation 1. And we have the value of sine B, we have the value of cos A and cos 2a. So we have to find out the value of sine A and cos B. Okay, so for that reason, I am finding out the value of these questions. Okay, so as you can see that from we have find out the value of cos A, which is equals to minus 3 by 5. Okay, so this is, we have an x by r. Now we can easily find out the value of sine A, which is equals to y by r. And as you know that the value of y is minus 4 and r value is 5. Okay, so we can easily find out the value of sine A. Now we have to find out the value of cos B. We have the value of sine B and we have to find the value of cos B. For value of cos B, So since we say that sine B equals to, we have a 4 by 5, okay? And the range is 90 to 360. Angle B must be in the second coordinate. So by using the equation, x squared plus y squared equals to r squared. So I'm just taking the value of x. From there, we have an x squared equals to r squared minus y squared. Okay, so x equals to, we say that r squared minus y squared whole square, and I'm just putting the values, which is, we have, sorry, minus into 4 square. Okay, we have an x equals to 25 minus 16, and we got 9. So we got, when we r squared minus 9, and we got x equals to 9, and we say that x equals to plus minus 3. So I'm using the negative value of 3 minus 3 because it is, because we have the range of B is 90 to 180, okay? So we can write it be like that. Cos B equals to x by r. So I'm writing here minus 3 by 5. Now we have all the values and we just put all the values in equation 1. Putting all values in equation 1. So what we have, a sine A minus B equals to, okay, we have a minus 4 by 5 minus 3 by 5 and minus into minus 3 by 5 into 4 by 5, okay? So 12 by 25 minus plus 12 by 25, and we got 24 by 25. Okay, this is the required answer for this expression, okay? The value of sine A into sine B is 24 by 25, okay? So move to the next question. We have a 5.2 is, if cos alpha equals to P, express the following expression in terms of P, okay? This expression cos into alpha by 2 minus 45 degree, sine into alpha by 2 minus 45 degree by 2. So they say cos alpha equals to P, and we express our answer in term of P, okay? So let's solve this question. So we're using the double angle identity over here by using double angle identity formula, which is, we have a sine 2 theta equals to 2 sine theta cos theta. So I'm converting my expression in this formula, okay? So let's see, we have a cos into alpha by 2 minus 45 degree and sine alpha by 2 minus 45 degree divided by 2. All right. We have this expression, and I am multiplying and dividing this expression by 2. Okay. These 2, we take it this side and we have to multiply and divide it, this whole expression. Okay. So we have a sine. We can interchange the values because they are in multiplication, okay? So sine alpha by 2 minus 45 degree and cos alpha by 2 minus 45 degree, okay? We do just simplification over here. This 2 we take outside and it becomes 2 sine into alpha by 2 minus 45 degree and cos alpha by 2 minus 45 degree. Okay, so we have now 1 by 4 into sine 2 dot alpha by 2 minus 45 degree. Okay, so you say that I just common 2 alpha by 2 minus 45 degree, okay, from the both expressions. Because it becomes like we say, you can see that we have a 2 sine theta cos theta. As you can see over in this expression over here, 2 sine theta and cos theta, and I'm just closing the formula. I'm just closing the formula, be like that, 2 theta. Sine, I just writing sine, put 2 and the value of theta. We have over here the value of theta is alpha by 2 minus 45 degree, okay? So we can write it like that. We have a sine like 2 and we say that this is equals to theta, okay, in the expression. So we have a alpha by 2 minus 45 degree, okay? So we can write it be like that, alpha minus 90, 1 by 4 sine alpha minus 90 degree. I'm using the double angle identity formula over here. And when we take alpha minus 90, so we have a minus sine. I'm just taking minus common over here. So we have a sine 90 minus alpha. Okay. So we have 1 by 4 into minus cos alpha, okay? Sine 90 minus alpha equals to minus cos alpha and minus we have taking over here. So we have 1 by 4 minus cos alpha. So as the given in the question that the cos alpha equals to, as given, cos alpha equals to P. So I'm just putting the answer minus 1 minus 1 by 4 P. And this is the required answer for this question. Okay. Now, the next is question number 6.1. Given the identity cos x minus y equals cos x cos y plus sine x sine y. So the first question is 6.1.1. Use the compound angle identity given above to derive a formula for cos x plus y. So we have a formula for x minus y. So we have to calculate the formula of cos x plus y. Okay. So let's start. We have to derive cos x plus y. We can treat x plus, like we have to derive cos x plus y, okay? So we can write it cos into x minus into minus y. Am I right? We can write it like that. If you multiply like minus y plus minus, so we got this value, okay? Same. So I'm just writing it be like that. So remember the cos into minus y equals to cos y, all right? So as you can see that if we have a sine into minus y, this is equals to minus sine y, all right? So I'm just putting the values. I'm taking over here a cos x plus y equals to cos into x minus into minus y, okay? So I'm writing the formula cos x cos minus y plus sine x sine into minus y. Okay. So as you know about that, cos into minus y equals to cos y, and sine minus y into minus sine y. Okay. So we have writing cos x. This is becomes cos y, and minus this sine minus y becomes minus. We take minus over here, and sine x sine y. All right. So this is the final derived identity. So we can say that cos x plus y equals to cos x cos y minus sine x sine y. This is the required answer, okay, for this question. So the next question is 6.1.2. All right. So we have to show that cos into 90 minus x cos y plus sine into minus y cos into 180 plus x divided by this whole thing equals to, we have to prove it is equals to 10x plus y. Okay. So we write the co-functions, and we can carefully write the reduction formulas. Okay. Firstly, so let's solve these questions. I'm writing the numerator reductions formula. Numerator reduction. As you know about that, cos into 90 degree minus x equals to sine x, as sine into minus y, as we see in the previous, equals to minus sine y, and we have a cos 180 degree plus x equals to minus cos x. Okay, I'm just doing this, solving these reduction formulas. Okay, now we have to solve the denominator. Sorry. Okay, so we have a cos 90 degree minus x equals to sine x, and sine into minus y equals to minus sine y. All right. So, sorry, I'm repeating the previous one. I'm repeating the cos. So we have a cos 360 degree plus y, which is equals to cos y, and sine into 360 degree minus x equals to minus sine x. Now we have taking the left hand side and put these answers like these reduction formulas. Okay, I'm taking the left hand side. Okay, so what is the left hand side we have? We have a cos into 90 minus x cos y plus sine into minus y and cos into 180 plus x divided by cos x cos into 360 degree plus y plus sine into 360 minus x sine y. Okay, so using the reduction formulas that we have solved previous, it is sine x cos y plus minus sine y into minus cos x. Okay? Now cos x, cos y minus sine x and sine y. Okay? I'm just going to simplify the equation. We got sine x cos y plus sine y cos x divided by cos x cos y minus sine x sine y. All right. So as you know about that, the above formula is sine into x plus y, and the lower is cos into x plus y. And this is equals to, as you know about the thing, theta equals to sine theta by cos theta, and we say that it is equals to tan into x plus y. And this is the right hand side we have to need. Okay. So now this question 6.2 is that given f of x, this is the function we have a given, square root of 6 sine square x minus 11 cos into cos 90 plus x plus 7. So solve for x in the interval of x belongs to 0 to 360 degree if f of x equals to 2. Okay. So first we have to substitute f of x equals to 2 and simplify the equation using the reduction formula that we have a cos 90 plus x equals to minus sine x, okay? And then solve the resulting quadratic in terms of sine x, okay? So let's start. I'm just putting the value of f of x, which is 2 over here, you can see, and we got a 6 sine square x minus 11 cos into 90 degree plus x plus 7. Okay, so as we can solve this thing at earlier, this by using reduction formula, it becomes 6 sine square x minus 11, and this is equals to minus sine x plus 7. Okay, this cos into 90 plus x. So I'm taking the square root on both sides. So first we have write the equation 6 sine square x minus minus plus 11 sine x plus 7. Okay, so now taking square root on both sides, we got 4 equals to 6 sine square x plus 11 sine x plus 7. All right, so I'm just make it a quadratic standard quadratic equation. 6 sine square x plus 11 sine x plus 7 minus 4 equals to 0. And the equation becomes 6 sine square x plus 11 sine x plus 3. All right. So as you can see that it becomes a standard quadratic form. So we have to factorize this be like that. You can write let k equals to sine x. Okay, so this equation becomes 6k squared plus 11k plus 3 equals to 0. All right, when you're solving this equation, you got it, the point, which is we have so I'm just applying the quadratic equation, which is we have k equals to minus p plus minus p squared, and we have a minus 4ac by 2a. So I'm just putting the values, sorry, in this quadratic equation. So what we got? Minus 11 plus into, plus minus into, plus minus into 11 square minus 4 into 6 into 3, okay? And we have a 2a. So just go to the simple into plus minus 121 minus, we got 4 multiply with 3 and 6, we have a 72 by 12, okay? So we got minus 11 plus minus 49 by 12 and minus 11 plus minus 7 by 12. Okay, this is the value of k we have to find out. So now we have to make it k equals to minus 11 plus 7 by 12 and k equals to minus 11 minus 17 by 12. So we have a k equals to 4 by 12 and k equals to minus 18 by 12. And this is equals to 1 by 3 and this is equals to and we have this is further equals to 3 by 2. So k equals to 1 by 3 and k equals to minus 3 by 2. So what the value of k we have? We have the value of k is sine x. So I'm just putting the value of k, which is sine x. So I'm writing that k 1 by 3 and sine x equals to minus 3 by 2. All right. So for the validity check, since minus 1 less or equals to sine x and sine x less or equals to 1. So the solution for sine minus 3x is not possible. So we did not use this solution. All right, we'll say that sine x equals to 1 by 3. And so for the general solution for sine x equals to minus 1 by 3 is the reference angle that the reference arc 1 by c arc sine into, we say that reference, okay, which is equals to reference angle that is equals to arc sine into 1 by 3. Okay, this is equals to 19.47 degree. So in the quadratic 3 coordinate, we say that x equals to 180 plus reference 180 plus 19.7 degree, which is equals to 199.47 degree. Okay. And in the fourth coordinate, we have x equals to 360 minus reference and 360 degree minus 19.47 degree, and that is equals to 340.53 degree. Okay, so we have an x equals to this. So the solution intervals, the solution intervals, we have an x belongs to 0 to 360 degree, and we say that x equals to 199.47 degree or x equals to 340.53 degree. Okay, so this is the required answer that we have to find out. So the next question is 6.3. Consider the function g of x, which is equals to 4 minus 8 sine square x by 3. So 6.3.1 is that calculate the maximum value of g. And 6.32 is write down the smallest possible value of x for which g will have a maximum value in the interval x belongs to 0 to 360. Okay, so first of all, we solve the 6.3.1. Okay, the function g of x we have, and we have to calculate its maximum value. Okay, so look for identities to simplify the function, specifically the double angle identity for cosine, and we have a sine 2x equals to 1 minus sine square x. Okay, so as you can see that the formula we have a cos into 2x, which is equals to 1 minus 2 sine square x. Okay, as you can see in the numerator, we have a 4 sine square x contains 1 minus, like we have in the denominator, we have a 4 minus into 8, 4 minus 8 sine square x. That is, we can write it be like that, 4 into 1 minus 2 sine square x, and we can write it be like that, cos 2x, as you can see. Okay, I'm just putting it be like that. We have a g of x, which is equals to 4 minus 8 sine square x and equals to 3. Okay, so like 1 minus 2 sine square x by 3 and 4 cos 2x by 3. Okay, so we apply the identity formula over here. So the range of cos 2x, range of cos 2x we have is -1 less or equals to cos 2x less or equals to 1. Okay, so the maximum value of g of x occurs when cos 2x is at its maximum. Okay, so we say that the maximum value of g of x occurs when cos 2x is at its maximum, which is 1. All right, so we say that g maximum equals to 4 into 1 by 3, and we have g maximum is 4 by 3. Okay, this is the required answer for this. So for 6.3.2, what we have? Write down the smallest possible value of x for which g will have a maximum value in the interval of 0 to 360. So the maximum value occurs of cos 2x is at 1. So we need to find the general solution for this and then find the smallest positive value of x. So we require cos 2x equals to cos 2x equals to 1. So the general solution of cos theta, the general solution of cos theta equals to 1 is theta equals to 360k, where we say that k belongs to integers. All right, so we can write it be like that, 2x equals to 360k, and we have an x equals to 180k. All right, so we are looking for the smallest value or in the interval below x belongs to 0 to 360. So we have to make a point if we say that k equals to 0, then x equals to 0 degree. Okay, so excluded by the interval that which we have 0 to 360. And if we say that if k equals to 1, then we have an x equals to 180 degree. All right, so the smallest possible value of x, the smallest possible value of x in the interval which is 0 degree to 360 degree is x equals to 180 degree. Sorry, we have an 80. Okay, so this is the required answer for 6.3.2. Okay, Now we have a question number 7. In the diagram below, the graph of f of x equals to tan x is drawn from the interval x belongs to minus 180 to positive 180. Okay, this is at, you can see that on a x-axis. It starts from positive 180 and minus 180. We have the interval. So the first question is 7.1. Write down the equation of asymptote of f in the interval of x belongs to 0 to 180 degree. Okay, 7.1. So we have the asymptotes for f of x equals to tan x occurs where cos x equals to 90. Okay, we say that the asymptote for f of x equals to tan x occur. This happen when where cos x equals to 0. Okay, so in the interval where x belongs to, we say 0, sorry, we can write it like 0 degree to 180 degree. So this happens when x equals to 90 degree. Okay, so we say that f of x, the asymptote of f of x equals to tan x when x equals to 90 degree. Okay, this is the required answer for 7.1. All right, so the next question is write down the values of x in the interval x belongs to 1 minus 180 to 0 for which f of x less or equals to 0. Okay, minus, this is minus 180 to 0. So let's solve this question. We have 7.2. Okay, so interval where f of x we say less or equals to 0. That is the given thing. That so based on the visual analysis of the graph, so f of x is equals to tan x in the diagram. Okay, the function is on or below the x-axis at the end point is x equals to minus 180 degree, and in the fourth coordinate range is we say fourth coordinate range is we have minus 90 degree to 0 degree. So we can say that x equals to minus 180 degree or x belongs to minus 90 degree to 0 degree. Or you can say that minus 90 degree less than x and x less or equals to 0. Okay, this is the required thing that we have to find out. So the next question is 7.3. The given is g of x equals to cos 2x plus 1. All right, so 7.3 having two parts, 7.31 and 7.32. 7.31, write down the period of g. Okay, 3.1. So the given g of x, we have g of x equals to cos 2x plus 1. And we have to find out the period of g. So the period is calculated as period is calculated as 360 degree by b, where b equals to 2. Okay, so we say that period equals to 360 by 2, that is 180 So the required answer is 180 okay? So what is the next part of this question? 7.32 is on the grid given in the answer book, okay? Draw the length of the graph g of x equals 2 of x plus 1. For the interval x belongs to minus 180 to 180, clearly show the intercepts with the axis as well as the coordinates of the turning points, alright? So this is how we have a graph, okay? So the vertical shift is q equals to 1, the range from 0 to 2, okay? This is we have to draw the graph, and we have a lower point at minus 90 and it's the highest point at the 0 to 2 range. The period is 180, okay? And the vertical shift q, right? And so the turning points at maximum y equals to 2 is minus 180 to 2, or you can say that 0 degree to 2 or 180 degree to 2. And the turning points for maximum at y equals to 0, so minus 90 and 0 degree, and these are also x-intercepts. So the graph should be concise way with two full circles, okay, cycles in the interval ranging from y equals to 0 to y equals to 2, all right? So this is the representation of the graph as you can see over here. So the next question is use the graph to determine the general solution of 2 cos cube x minus sine x equals to 0, okay? So use the graph to determine, so we assume that we have a 2 cos cube x minus sine x equals to 0 to allow substitution leading to g of x equals to f of x, all right? So we can write it like that. 2 cos cube x minus sine x equals to 0, okay? So we say that 2 cos cube x equals to sine x, and we have 2 cos square x equals to sine x by cos x, and 2 cos square x equals to tan x. So as you know about when using that identity formula, which is about over here, the formula that we have a 2 cos square x equals to cos 2x plus 1. Okay, I'm using over here. We have a cos 2x plus 1 equals to tan x. And this is we have a g of x, and this is we have f of x. So the solution is the intersection of the two graphs, g of x and f of x. So by the inspection, the graph intersect at, we say that the graphs intersect at x equals to 45 degree and x equals to minus 35 degree, okay? So since the period of the resulting function is 180, the general solution is we have x equals to 45 degree plus k dot 180 degree, and k belongs to integers. So this is the required answer for this question. Now we have a question number 8. In a diagram, C is the foot of the vertical building and D is the top of the same building. Okay, as you can see, this is the C point, this is the D point, and the height of the building is CD is 16 meter. Two observers standing 19 meter apart from point A to point B. Okay, this is the point A and this is the point B, and where A, B, R, and C lie on the same horizontal plane, as you can see over here. A painter is working at point E. This is the painter working point on the building. The angle of elevation of the D from A is 46.85 degree, and DE B equals to 122 degree, and BCA equals to 105.61 degree. Okay. Now, the question number 1 is 8.1. Calculate the length of AC, the distance between the observer at A and the foot of the building. Okay, we have to calculate the length of A, A to C. Okay, this is we have to find out the length. Okay. So let's solve it. We have an 8.1. Okay, so we use the right angle triangle. We have right angle A, C, D in the vertical plane. In the vertical plane, okay, which is angle ACD equals to 90 degree. Okay, so we can write it like 10 into angle DAC. DAC equals to opposite by adjacent. Okay. So the angle DAC is, we have a 10 into 46.85 degree, and we have CD by AC. So 10, 46.85, 85 degree equals to the value of CD is 16 meter, and we can easily find out the value of AC, which is 16 meter by 10 into 46.85 degree. Okay, now when you go to solve the 1045, after the simplification, we got the value of AC is 15 meter. Okay, so this is the answer of first question that we have required. Now the second question is 8.2. So what is the second question? Calculate how far the painter at E is from the top of the building. Okay, you see over here, this is, we have the painter E, this point, and we have to find out the distance from E to this top of the building is D point. Okay, so let's do it. So first of all, we have find the length of BC. Okay, we say that horizontal triangle ABC. All right, so use the cosine rule for that. We're using the cosine rule by using cosine rule. Okay, so what is the cosine rule we have to use? This is the representation of this graph, that we have the angle that this is the angle 122 degree. This is we have an angle 46.85, and this is the angle 105.61. Okay, so they are given us that we have an AB which is equals to 19 meter. We have an AC that is 15 meter, and we have angle BCA which is 105.61 degree. Okay, so I'm putting the value. We have the formula is AB square equals to BC whole square plus into AC whole square minus 2 into BC AC, and we have a cos into angle BCA. BCA. Okay, so I'm just putting the values in this equation. We got over here 19 square equals to BC square plus into we have a 15 square minus 2 into BC into we have a 15, and we have a cos into 105.61 degree. Okay, so we do this just simplification, more simplify the equation. So we got over here 361 equals to BC square plus 225 minus 30 BC into minus 0.2705. Okay, so after doing more simplification, we get 225 plus 8.115 BC. Over here we have 361. So I'm converting this into the quadratic standard form. Okay, so we have BC square plus 8.115 BC plus 225 minus 361 equals to 0. Okay, as you can see that we have this is the form of standard quadratic, okay, equation. So we have a BC square plus 8.115 BC plus, sorry, we have an over here a minus because we put the minus over here, minus 136. Okay, so what we apply the quadratic equation, or you can it's factor it out. So I am applying quadratic equation. We have BC equals to minus 8.115 plus minus we have an 8.115 whole square minus 4 into 1 and into minus 136 divided by 2 into 1. Okay, so after doing the simplification, we got the value is minus 8.115 plus minus, you're just taking the square root and this minus multiply with this minus 4, we becomes positive and add up the values, and we got then take the square root, and after taking the square root we got sorry, we have a so I'm taking this, I'm removing the, sorry. Okay, So this is 24.695, okay, and divided by 2. So we take BC equals to approximately equals to 8.29 meter. Since length cannot be negative, we got a one positive value and one negative value. So I take the positive value because since length cannot be negative, so we discard the negative solution in this, okay? So I take the positive value of BC. Now, now we find the vertical length of, now we find the length of CE and the vertical triangle BCE. BCE, okay? So to find CE, we need an angle in the right angle triangle BCE. So the angle is at C at 90. So the angle of DEB is 122 is given, okay? So in the triangle BDE, as you can see over here, over it, okay? So in the triangle BDE, BDE, okay? This is the triangle. If we like draw it be like that, okay? BDE. We must use the sine rule or cosine rule, but the simplest path is implied by the official solution. We can determine the angle BCE. BCE, okay? This triangle, this little triangle, as you can see over here. So we resume the calculations and EC equals to 5.919, and which is the angle is EBC is 32, okay? We calculated this angle from the geometry of the shape. So I'm writing over here that tan, I say EC equals to 5.19 meter, and we have angle EBC is equals to 90 degree, okay? So I'm writing tan into angle BC, EBC equals to EC by BC. So we have a tan 32 and EC, and we have BC value is 8.29 meter, and we get the value of EC from here is EC equals to tan 32 degree by, oh sorry, we haven't multiplied this term. I'm just we multiply with 8.29 meter. So we got AC equals to, we got the value is approximately it is equals to 5.18 meter. All right. So we use 8.30 as the G. Okay. So this is round about like 5.19. Okay. So now we calculate the distance of DE. All right. Now this is equals to 5.19. Okay. Now we calculate the distance. Now calculate distance of DE. Okay. So see, since D, E, C are on the vertical line, since DEC, DEC are on the vertical line, and CD we have 16 meter. So DE equals to CD minus EC. All right. So we have DE equals to 16 minus 5.19. That is equals to 10.81 meter. All right. So we say that the painter at E is 10.81 meter from the top of the building. Top of building D. And this is the required thing that we have to find in this question. Okay. Now we have a question number 9. In the diagram, A, B, C, D is a cyclic quadrilateral. Okay. So BC is produced to E and AC is drawn. So A1 we have 1 by 2B and A2 equals 46 degree and C1 equals to 86 degree. Okay. So we have two questions of 9.1 is calculate with the reason the value of A1. Okay. And the second question is prove that AD equals to DC. All right. So the first question is that we have a given, we have to calculate with a reason the value of A1. So A, B, C, D is a cyclic quadrilateral. Okay, so C1 is equals to, we have 86 degree, and A2 we have 46 degree. Okay, so angle, first thing is that the first point we have angle DAB equals to C1. So exact angle of the cyclic quadrilateral and equals to the opposite angle. Okay. So the second thing we have is A1 plus A2 equals to C1. Okay. Third point is that A1 plus, put the value of A2 which is 46 and the value of C1 is 86 degree. Okay. So we can find out the value of A1 over here. A1 equals to 86 minus 46 degree. So A1 equals to 40 degree, and this is the required answer for 9.1. Now, what is the, in 9.2, prove that AD equals to CD, all right? So in 9.2, we have to prove that AD equals to DC, all right? So to prove AD and DC, we must show the angles opposite these sides in triangle ADC are equal. That we say that angle ACD equals to angle DAC. And we already know about that angle DAC. Angle DAC which is equals to A1, that equals to 40 degree. Okay. So we need to show the angles ACD, okay, which is C2, angle ACD. This is angle ACD, which is C2, right? Is also, this C2 is also equals to 40 degree. So let's show that how we say. So we have a B which is equals to 2 multiply A1. Okay, we find out this value from this. A equals to 1 by 2 B. Okay, from this I take out the value of B. So I'm just putting the value of 2 multiply 40, which is equals to 80 degree, and then B plus B, which is equals to 180 degree. Okay. So we say that a D equals to 180 minus, we put the value of B, which is 80 degree, and we get 100 degree, the value of D. Okay. So in triangle ADC, in triangle ADC, angle ACD equals to 180 degree minus into D plus angle DAC. So sum of the all angles of the triangle. So we have angle ACD, which is equals to 180 degree minus 100 degree plus 40 degree. Okay. So we say that angle ACD equals to 180 degree minus 100 degree minus 40 degree. And we got the value is 40 degree. So angle ACD is also equals to 40. So we say that angle ACD equals to angle DAC equals to 40 degree. Now we can say that we have AD equals to DC. Sides opposite equals to angles. Okay, this is the required thing that we have to find out in question number 9. Now we have a question number 10. 10.1. In the diagram of triangle RST is drawn, line AB intersect RS and RT at A and B respectively, such that AB parallel SD. Prove the theorem which states that a line drawn parallel to one side of triangle divides the other two sides proportionality. So RA by AS equals to RB by RBT. Okay, so we have to prove it by a theorem. So let's do the solution of this work we have now. All right. So join SB and TA, draw a height from B perpendicular to AR. Okay. So as you can see over here. So this is says we have to draw. Okay. So this is we have to draw. Join SB. We have to join the SB and TA, okay? And draw a height of H1. This is the height of H1, and from B perpendicular to AR, and draw a height H2 from A to perpendicular to BR, okay? So now we have to prove that. Consider the ratio of the area. Consider the ratio of areas using heights from B. Using heights from B, this B point, okay? Now, what we have to do the next? So we have an area triangle RAB divided by area triangle SAB. So I'm writing over here 1 by 2 RA divided by, multiply with H1 and divided by 1 by 2 AS multiplied by H1. Okay. So this is equals to RS by AS. Ratios of areas common height H1. Okay, in this. So the second point is that consider the ratio areas. We have to consider the ratio areas using height from B. Okay, using height from B. Okay, in the previous one we used the height from A, H1. Sorry, using the height from A. In this we have A. In the previous one we have a height from B, and in this one we have the height A. Let me check it out. Yeah. So how we write the area of triangle RAB divided by area of triangle TAB, which is equals to 1 by 2 RB multiplied by H2 divided by 1 by 2 BT divided by H2. Now this is equals to RB by BT. All right. Now consider the third point you have to consider. Consider triangle. Consider triangle SAB and triangle TAB. So area of, we say that area of triangle SAB equals to triangle del TAB. All right? So what we say, substitute 3 into the denominators of the ratios derived from 1 and 2. Okay? So we have an area del triangle RAB divided by triangle SAB equals to area triangle RAB divided by triangle TAB. All right. So therefore from 1 and 2, this is from 1 and 2, we see that RA by AS equals to RB by BT. Okay? From these 2 points, we say that the required thing. Okay? Now, the next question is 10.2. In the diagram of O is the center of the circle. This is the O point. And triangle PWS is drawn with P, W, and S on the circle. O are perpendicular to B as this O R, okay? Perpendicular to PS. PRS is produced to T, SW and OT is intersect at V. So OV ratio OT equals to 1:4. All right. Now we have two questions of 10.2. So 10.21 is prove with reason that OR is ratio WS equals to 1:2. All right. So we have to prove this firstly. And secondly, we have to calculate the length of PT if ST is 15 units. Now, firstly, we have to do a 10.21. All right. So identify the relationship between PR and RS. So first of all, we have to identify the first thing, identify the relation between PR and RS. Okay. So the relation is PR equals to RS. Reason is that, what is the reason? Reason is that line from the center O perpendicular, we say that line from center O is perpendicular to the chord of PS that bisects the chord. Okay, so state the relationship between the radii. The second point is we have to state the relationship between the radii is PO equals to OW. Okay, so reason is that, what is the reason behind that? Radii of the circle. Okay, so the third point in this, that in triangle BWS, triangle PWS, okay, R is the midpoint, R is the midpoint of PS, and O is the midpoint of W, and O is the midpoint of PW. Okay, since PW is a chord passing through the center O, it is diameter. So we say that a correction is that a PW is not necessarily a diameter unless when we have angle WSP equals 90 degree, or W is a directly opposite to P. So PO and WO are radii. So PO is equals to WO. Thus, O is the midpoint of the line segment of the BW. So, applying the midpoint theorem, okay, we have now, by applying the midpoint theorem, okay, in triangle PWS, what we have? OR is parallel to WS, and OR equals to 1/2 WS. So reason is that midpoint theorem, line joining midpoint of two sides of the triangle is parallel to, okay, so this is the 10.21. Okay, this is the what we have to require in the question number 1. Now move to the next question, which is about 10.2.2. Okay, so we have to calculate the length of PT if ST is 15 units. So use the proportionality in the triangle TSW. As you can see from the marking guideline implies the result from triangle TSW, and the parallel lines are O parallel SW established in like 10.21, which leads to the ratio R S by ST equals to OV by VT, which is equals to 1 by 3. So we can say that OTR by, as you can see over here, the ratio, like I am writing over here, that TR by RS equals to TO by OV equals to 4 by 1. And this is the how. So the ratio RS by ST equals to 1 by 3 must be established from the given ratio OV ratio OT equals to 1 ratio 4. Since OV ratio OT is equals to 1 ratio 4, let OV equals to X and OT equals to 4X, then OVT equals to OT minus OV equals to 4X minus X equals to 3X. So therefore, we write OV by VT equals to X by 3X. Now X is cancelling and we get the value is 1 by 3. All right. Now just writing over here the values of our calculator. We have to calculate RS. So what we have, RS, like ST is 15. ST is 15 units, okay? So RS by 15 equals to 1 by 3. So RS equals to 1 by 3 multiplied by 15. And we got over here, answer is 5. Okay, so we say that RS equals to 5 units. Okay, so we have to calculate PR. So as you know that RS equals to PR, so it is also equals to 5 units. Okay, now reason is that line from the center O perpendicular to the chord PS, that's why. So we need to calculate PT. So PR, ST are collinears. So we can say that PT equals to PR plus RS plus ST. That 5 plus 5 plus 15. And we got 25 units. PT equals to 25. Okay, and this is the required answer of this question. So this is the last question, question number 11. In the diagram of A, B, G, and F lie on the larger circle, as you can see that A, B, G, F, okay? A smaller circle is drawn to touch the larger circle internally at A point, okay? This is the smaller circle and this is the large circle. So EA is a common tangent to both circles. EBCF is the tangent to the smaller circle at C. So AC is produced to G. AF cuts the smaller circle at D. AB, CD, and GF are drawn. Okay. So here we have parts of question number 11. We have an 11.1. If EAG equals to X, determine with vision 4 other angles that are equal to X. Okay, we have solved this question. All right. So, first of all, we have a first angle, which we say G2 equals to X. This is the G2. Okay? This is the G2 angle. All right? So the reason behind this is tangent chord theorem. Tangent chord theorem. Tangent EA and chord AG of the larger circle. Okay? The second angle is we have F1 equals to X. What the reason behind this is angles in the same tangent. Angles in the same segment. Okay? That means that subtended by arc AC on the larger circle on the larger circle, which is we say that F1 equals to G2. Okay? So the third angle is C3. C3, which is equals to X, and we say it is a DCG. Okay? The reason behind this is tangent chord theorem. Tangent chord theorem. And the tangent EA and chord, we say that I'm writing over here, tangent EA chord AC of the smaller circle of the smaller circle, then we say EAC is the angle in the alternate segment. In the alternate segment. Okay, so since AC is a straight line to G, since AC is straight line to G and EAC is not X. So we must assume that EAC equals to C3. Okay? And C3 equals to X. Now the fourth angle is D1 equals to X. Okay? And we say that it is ADG. So the reason behind that, angle subtended by same arc AC on the smaller circle. Okay? Angles subtended by the same arc AC on the smaller circle. Okay, so that's why we say that in zooming, A2 or D1 is equals to EAG due to the common tangent EA at A. And we say that this is the point of contact. So we assume that A2 equals to X. All right. So this is the required angles for the question number 11.1. And for 11.2, over here, as you can see there, prove that AG dot AD equals to AC dot AF. Okay. So we have to prove it. We have an 11.2. Prove that AG dot AD equals to AC dot AF. Okay. So we need to prove this in ratio, and which implies that over here we have to prove that AG by AD equals to AC by AF, and which implies triangle AGF, triangle ADC. Okay, so in triangle ADC and AFG, so in triangle ADC and triangle AFG. So the first thing is A2 equals to A2. All right. So what that mean? We have say that CAD equals to FAG. All right. So the reason behind that is the common angles. The second thing is we say D2 equals to G1. All right. So what we have ADC equals to AGF. All right. So the reason behind this is angles subtended by the same arc. Okay. So we say that we use the property of the point tangency that D2 equals to F2, and we say that we have to use it by the third point is that let's use the property of point of tangency, okay, A. So D2 equals to F2, and we say that it is ADC equals to AFG. All right. So the reason behind this thing is the angles subtended by arc AC on smaller circle are equal. Okay. So D2 equals to DF2. So if we say triangle ADC equals to, we say parallel to, triangle AGF. So ratios of the similar triangles, we write it AD by AF equals to AC by AG, and which is also equals to DC by FG. So we can write it in our given form. We say that AG dot AD, okay, equals to AC dot AF. This is the required. We have to prove that. Now, the next question is 11.3. Okay, so in 11.3, we have to prove that um, prove that triangle AGF parallel to triangle ABC. All right. Now we have to prove this. So the first thing is in triangle AGF and triangle ACB. So first thing is that F1 equals to B1. So what we have to write at AFG means that the angle is at F, okay? This thing is meant. A, B, C. So a reason behind this is because we have to given the reason of at every point. Reason is angles in the same segment. Angles in the same segment, okay? So subtended by arc AG on the larger circle. And the second thing is we say G2 equals to C1 AGF equals to ACB. So what is the reason behind this? Reason behind this angles, same be like that above, angles in the same segment. And over here, the subtended by arc AF on the larger circle. Okay? Subtended AF by arc AF on the larger circle. And the third thing is over here, A3 equals to A1 and FAG, sorry, we have an equals to CAB, okay? So the reason behind this is third angle of triangle, okay? This is third angle of triangle, which we say that, or we can write it be like that, A3 plus ABCF equals to 180 degree. Okay, so we can prove it that triangle AGF parallels to triangle ACB by angle and angle. Okay, so The next question is 11.4. 11.4, okay? So prove that GF square equals to BC dot FC dot AF divided by AD. All right. So we have to prove this. Now, from previous question 11.3, we proved that the ratios from previous question to prove that del AGF parallels to triangle ACB, and the ratios we have proved with GF by CB equals to AF by AB, and we find out the value of GF, which is AF dot CB by AB. Okay, let me just clean this. We have a CB over here. Now, squaring the expression, I'm taking the square root of this expression. We got GF square equals to AF square dot CB square divided by AB square. All right. So by using the ratio, AG by AC, AG by AC equals to AF by AB. Now, I am taking the value of AB from here, from this ratio. So, AB equals to AF dot AC divided by AG. Okay. Now, we're taking the square root. Now, we put the value of AB in the squaring of GF square, all right? So we have a GF square equals to BC square dot AF square. And now I'm putting the value of AB over here because we have an AB over here. So I'm just put this value of AB. So which is we have an AF dot AC by AG, okay? And taking the square root. This is all square root, okay? Now, what we've got? We have a BC square dot AF square dot AG square by AC square dot AF square. And what we have? GF square, okay? Now, as you can see that we have an AF square, F square cancel out. So we get GF square equals to BC square dot AG square and divided by AC square. Now, by using the ratios again from 11.2, what we get? So by using the ratios from 11.2, what the ratio we have? AG by AC, that is equals to AF by AD. And now we can write it like that, AG by AC equals to AF by AD, all right? So we have to substitute AG by AC into the expression of GF square, okay? By putting the value of AC by AG in GF square. So what we got? We have a GF square equals to BC square dot AG by AC square. Okay, and what we got? We have equals to BC square into AG by AC. What we have? AF by AD square. Okay. After doing some simplification, GF square equals to BC square dot AF square by AD square. Okay, so the target expression is GF square. We have that a BC dot FC dot AF or by AD. So this implies we need the relationship of BC dot AF by AD equals to FC. All right, so assume that assume BC dot AF equals to FC dot AD. All right. So we can rewrite the derived results be like that. GF square equals to, we have a BC square, AF square by AD. So I am writing it be like that. A BC dot AF by AD. Okay. And BC dot AF by AD. Okay, when we multiplying these two terms, we're getting this expression. So I'm just open the expression like that. So now I'm substitute the value of FC. FC equals to BC dot AF by AD. Okay, I'm just put the value of FC in this expression. Okay, so we got GF square equals to BC dot AF by AD, and this whole expression, we say that it is equals to FC. All right, so now we have a GF square equals to BC dot AF dot FC by AD. Okay, so this is, we have to prove it, the required thing of 11.4. Okay, thank you.